Okay, are you able to see the screen?
Yes, yes.
Great. Okay, so Bismillah ar-Rahman ar-Rahim. For the last maybe 1.5 lectures, we have been talking about software construction. And we first had a last Thursday on something called snapshot diagrams. And we looked at, how we can look and understand and graphically represent the state of an object at a runtime. And we looked at the concept of, mutable and unmutable objects and so on and so forth. And then we looked at specifications on Thursday. Sorry, on Sunday we looked at why we need to do specifications, and just to very quickly remind and refresh our minds, we looked at the concept of or an example of the big integer implementation, and we realized that it's very hard for us to even understand that small piece of code. And when we looked at the specifications, they were so easy, straightforward, clearly told us, what are your input parameters, what are your preconditions, what are your post conditions. So we had a bit of discussion on the structure of the specifications as well, and we understood that at the end of the day you are writing specifications so that you can decouple the implementation from the clients of that method. And when you do that, basically clients will give you or satisfy the preconditions, and they are guaranteed a post condition. If they don't satisfy the preconditions, so if they don't satisfy the preconditions, the post conditions are not guaranteed or undeterministic or undetermined, and so on and so forth, right? So basically, we looked at all of that stuff. If you just to very quickly refresh again, we looked at examples of the find one, right? The find array, and where you can find your elements in an array by starting from the index 0 going all the way to the length, or you can do the other way around as well. And we can specify that, we can tell exactly what your inputs will be, your preconditions will be, what your post conditions will be. So if you just remember this one, I think this is where we stopped the other day. We said we can have a specification where we are muting the objects themselves. And what's happening here, if you refresh your mind, you have a method called add all. You are passing on two lists, and you're modifying the list L1, hence it's muting, right? We talked about these in detail the other day, right? All of this stuff, and probably we stopped somewhere here. So, let's look at another example. What's happening in this case? Can someone help me understand this?
It's like producing a constant.
Mm-hmm. So basically, what you're really doing is you're sorting an array. And in this case, we're saying that we're going to pass you a string list, and just to make things clear, you don't sometimes have even preconditions. So basically, in this case, you will just say your requires are nothing. You don't have any precondition. And what's your post condition is that once a string array is passed to you, we'll put the this string array in the sorted order from going from index 0 all the way to the length, right? Now, are we changing the list itself? So are we changing this list, or we are creating a new list as per this specs?
We are changing the list.
We are changing the list. Hence, we are saying that this is an example of a muting method, right? Where the method is muting, where it's actually changing, the in this case, the list itself. Now, let's look at another example. What's happening in this case? So again, we have a method called toLowerCase, right? And we're gonna pass on a string list. Again, nothing, no preconditions in this case, so we'll just say nothing. And by the way, this example, I brought this here just to point out to you that, it's not a necessary thing that you're always going to have a precondition, right? So, you can just simply say nothing. Now, what's happening here? As a post condition, we are saying that we'll be returning a new list. Okay. So are we telling that this time around we are creating a new list or changing the existing one?
A new list.
We're creating a new list. Hence, this is an example of a non-mutable argument, right? Everybody's comfortable with this? I think so, right? It's very straightforward. Now, can you guys have a read of this one, what I'm saying here? No. The reason I'm showing you both options is that, you can do both. It's up to you as a designer, which one you want to show. But we'll be using this convention that, mutation is disallowed unless stated otherwise. So this is just a convention. And for example, this spec of toLowerCase could explicitly state as an effect that list is not modified, right? But in absence of a precondition describing mutation, we demand no mutation of the input at all. Is this point clear to everyone? This convention.
Yeah. Could you please repeat it?
Okay. Sorry, what happened to my mouse? Strange. Okay, so let's look at one more time. What's the convention we're telling here? The convention is that mutation is disallowed unless we explicitly state it. All right. So whenever you're going to write a spec, our convention will be that the effects in our post conditions, we will not be saying that, that we are mutating, the argument or the variable or the data itself, right? So this is just a convention. So for example, in this case, this toLowerCase could explicitly state that an effect that list is not modified, right? You can explicitly say it. Or, but in absence of a post condition that describes mutation, we demand no mutation of the input. So if it doesn't say that you have a mutation, then you will have no mutation. We don't expect to have mutation of the input. It's just a convention. The point to take away here is that whenever you're going to write your specific, you have to basically, as part of your post conditions, you will have to tell whether you are, what are you returning? Are you returning a new, in this case, for example, are you returning a new list or you're just returning the same list, right? And this will be clearer to the developer that what needs to be done here. No, but this is just the basics we talk about, inshallah. This is something, maybe a couple of slides I was not able to finish on Sunday. So I thought maybe let's finish this one and let's come to today's topic, which actually takes us to the actual level of discussion I want you guys to have as part of your 316 design, concept. So just in a nutshell, your specifications acts like a firewall between your developer and implementer of a procedure or a method and its clients. We all know this, I believe so. Everybody seems to be comfortable about this concept. And it basically, it decouples it. It decouples these clients and implementers in such a way that client is free to write a piece of code to use this procedure without really needing to know the source code at all. So if you have specifications, the client does not need to know the source code, then doesn't need to know the pseudocode of it, doesn't know how it is written. All he needs to know that if I pass on these preconditions or if I satisfy these preconditions, I'm guaranteed a satisfaction of a certain post condition. while at the same time you are giving implementers a complete freedom to the way go on and write this method, this procedure, without really worrying about how it will be used, who will be using it, when it will be used, right? Everybody's comfortable with this point. This is what I want you guys to know till this stage. I think everybody is, I'm expecting everybody is comfortable with this. Some show of hands, guys, if you just give me a bit of confidence before I move to the next level. Thank you very much. So let me stop the sharing of this one and move on to today's one, inshallah. Okay. Oops, what happened here? I lost track of, which one was shared. Okay, this is good now, right? You are able to see the screen now, right?
Yes, we can see it.
Okay, great. Now, since we know the basics, now what we're going to talk about is we're going to talk about design specifications and how we can design our specifications. And this is something I want you to know. Now, and then we'll be, looking and understanding that, what is the meaning of, under determined specs and how to identify and assess these non-deterministic and deterministic specifications. We'll be looking at, what's the meaning of the declarative and operational specifications, right? And we'll be looking at, how to understand the strengths of our preconditions, post conditions, and overall the specs, and how we can use them to compare two or more specifications. Now, the reason we'll be talking about these things is that, as was the case when we were talking about, if you recall, when we were talking about the architecture, right? When we were talking about the packages and when we were talking about the stability matrices and abstract stability matrices, even we were talking about, solid principles. We were talking about that as a designer, I have to have, I have to think about multiple options I can do the same thing. And then you basically go on and analyze and say that, for a given problem, this is a better solution, correct? This is the whole idea of the whole design course. So similarly, now, because you know the basics and you appreciate that, that specs are helpful, we are going to try and understand now that, how I can write good specifications. Okay. And for that to happen, uh, we will be, looking at, how we can compare our specifications, because for us to come up and decide that certain specification is better than the other, we'll have to first look at and understand that, specifications may have similar behaviors. And we might have to talk about, the trade-off between these specs and which one is better than the other. And we will be doing this comparison. We'll be doing this comparison using 3 dimensions. I like your special attention for this because this is the core of today's discussion. Now, before I show you these dimensions, everybody's on board with me why I'm going to show you these dimensions, right? Why we are interested in knowing these dimensions. We are interested in knowing these dimensions because when you write as a designer, you're going to write specifications. You can write them in multiple ways. First of all, we'll see, what are the different ways we can write them. And then we'll talk about at the end, probably if we don't have time today, probably on Thursday, how we can write good specifications. But let's understand what are the different ways we as designers can write specifications or end up writing a specification. So our first dimension is how deterministic a specification is. And this really means what? It means that does the spec defines only one single possible output for a given input, or it allows the implementer to choose from a set of legal outputs. This is our first comparison criteria. Our specifications are deterministic in nature or underdetermined or non-deterministic in nature, right? Second dimension you have is called declarative, right? So we will see that, does our specs just tells us what the output should be, or does it give us explicitly how to compute the output, right? So when we write specs, uh, are we telling what the output will be? And simply is this, or are we really telling, how to go step by step, do this, do this, do this, and then get the output? And this will help us compare, two or more specifications based on the dimension of declarativeness. And the third one is how strong is this, which basically means, does the specs have a small set of legal implementation or it has a larger set, right? That can I satisfy the specs by only, one or two ways of implementing it, or and I can satisfy the specs by a multiple range of different implementations or algorithms or logics, right? So we'll be understanding each one of them with examples naturally, but are you guys on board with me here that, why we are interested in comparing specifications and what are the dimensions we'll be using to compare? Anybody who's not sure about this? I can explain this again.
Uh, Doctor, please, what's the difference between the first one and the second one?
The deterministic and declarative?
Yes.
Okay. I will suggest that, the difference will become clearer when I'm going to go through this next round of slides very shortly, right? So just bear with me. But at the moment, just keep in your mind that I am going to compare specifications and I'm going to compare them on 3 dimensions. Or I can compare them by 3 dimensions. Deterministic, declarative, and strong. Okay. Now, what's the difference between them? It inshallah will be clear in maybe next half an hour, inshallah. All right. Okay. So let's look at this now, inshallah. Now, not all specs for a given module are equally useful. And we explore what makes some specifications better than others. This is the whole idea of, understanding how we can design specifications and how we can come up with better specifications, right? Because we know, as was the case in architecture, as was the case in packages, that, you can come up with a package structure or a structure or packaging of your classes in 4, 5, 6, 10 different ways. But some of others, right? Some of them. Similarly, you can have multiple specifications of your modules, but they're not, they're not equally useful. And of course, we want useful ones. We want good specifications. So let's look at the first dimension, right, which is our deterministic one. Let's read this one more time. Guys, can you read this one for me, please? So we will say that, we will be trying to understand whether this specifications defines only one single output for a given input, or it gives you a choice of a range of legal outputs. Now, remember this piece of code the other day on Sunday, we looked at this one, right?
Yes.
All right. So what is happening in this piece of code?
Showing the first occurrence of a number in an array.
Exactly. So we have a value, we search from it, we search from the index 0, go all the way to the length. The moment that array is found, we return that index. Otherwise, we return the length of the array. And do you recall this one as well, right? That was another implementation. It was the other way around, right? We're looking for a value in an array. We start from the array length, go backwards. The moment we find that element, we send that index, return that index. Otherwise, we'll return -1. Now, so this is our implementation 1. This is our implementation 2. Now, one possible specification of find, and I think I showed you this on Sunday as well, is this one. All right. So what this specification is telling you?
That this method is exactly has one value of this one of val.
Exactly. So basically, what is your precondition here?
Array has one occurrence of one number.
Exactly. So the array has only occurrence of one number here, and since it has only occurrence of one number, you will be returning the index of it, right? Now, do you believe this is a deterministic specification or non-deterministic / underdetermined specification? Let's look at the definition one more time.
I think it is non-deterministic because what if we don't find the specific value, the val value in the array? What will happen in that case?
Okay, so okay, I'll hold on to your observation, which is a very interesting one here. So basically, we are telling here is that what if my input has a, you know, so I have these elements 1, 2, 3, and 4, and I'm searching for number 5, correct? Right? That was the question, isn't it? Great, great, Hussein. So basically, first of all, I believe it's deterministic. And the reason it's deterministic is because if we go back to our definition, it says that the specs define only one single possible output for a given input, right? It doesn't give you a range of, legal outputs. What was happening here is that, when we present with a state that satisfies the precondition, the output is completely determined, right? Now, what will happen in this case? Are we going to satisfy the precondition?
Yes, we are. Well,
No, no.
No, in this case, no.
In
Val
this
does
case,
not
no.
exist.
It does not exist because val occurs exactly one in the array, right? So see, this is, and this is a very good question. Jazakumullah khair, because this will clarify all the potential misconceptions we might have. Excellent question. Because see what's happening here now. If you satisfy the precondition, what was the guarantee?
it will return the index.
Yeah, so the guarantee was it will satisfy the post conditions, right?
Yeah,
In this case, it will return the index. Now, if I don't satisfy the precondition,
it's fine.
is undetermined, right? It's not, we don't know, right? No promises there, right?
Yeah,
So in this case, if I give an array which does not has the value, am I satisfying my precondition as written by this specification?
No.
No. So if I'm not satisfying my precondition, this behavior is undeterministic, which is this behavior is undetermined, which is exactly what we observed, right? But for this function to work, this is the beauty of the specs, that you are telling me that if you want to use this function, you have to satisfy the precondition. If you satisfy the precondition, I guarantee satisfaction of the post condition here, right? So if this is going to happen, that I'm satisfying the precondition, let's say rather than I'm looking for 4, I'm looking for a value, rather than looking for a value 5, I'm looking for a value of 4. Am I satisfying now the precondition?
Yes.
Since I'm satisfying the precondition, I'm guaranteed that I'll be returning an index of it, right? I expect that my post condition will be satisfied, right? Now, by looking at this, do you believe that it's a deterministic specification?
Yeah, yeah.
Right? Everybody's on board with me on this now, right?
yes.
Great. Let me also follow the chat here. Well, here, yeah, no trigger, probably yes. Okay. So only one return value and one final state is possible. Is there any way possible that if I satisfy precondition, I can have multiple outputs?
No.
No.
No, it's not possible, right? So for there are no valid inputs for which there is more than one valid output. Right? So as long as I don't have any valid inputs, we're going to have multiple valid outputs. In this case, we can clearly and safely say that this specification is deterministic in nature. Right? For a specs defines only one single possible output for a given input. So far so good, guys. Okay, so which implementation can I use to satisfy this one now? Remember, at the end of the day, this specification is going to act like a shield between the implementer and the client now, right? So from an implementation perspective, which of these implementation he can select to implement it?
Any one of these.
Exactly, any one of these, right? He can go on and select the find first, right? Or he can go on and select the find last, does not matter, as long as, it's implemented correctly, the specs are satisfied. So basically, as we just observed, both find first and find last satisfy the specification. So if this specification is, so if this is the specification on which the client relies, basically, two implementations are equivalent and substitutable for one another. Everybody's cool with this?
Yes.
Okay, great. Now, let's look at a slightly different spec now. Same system, same example, but a different specification now. What's happening here now? So rather than specifying this way, I'm specifying now like this. So what it's telling me?
This is not deterministic.
Exactly. This is not deterministic. Why?
Because if val occurs 2 times, I don't know with which index will be returned. The first one or the second one.
True. Absolutely true. In other words, it depends on if I implement the find first or implement the find last, right? As a developer, right? The value which is returned will be different, right? Especially in the case we have multiple values in the array, right? And precondition is not saying that it should be exactly one, right? So it's very open, correct?
Yes.
And so see, by writing the specs as a designer, this is one way a designer can write a spec. This is another way a designer can write a spec, right? And some of the specifications will be deterministic in nature, some of them will be underdetermined or / non-deterministic in nature, right? As is very evident from this case. As a result, it depends on how the developer implemented it. Client, has to understand how it was implemented, right? Or somehow know, because it can potentially lead to what you call misunderstandings, because he may say that client may assume here that the code will return me the first index, while the developer actually developed the other way around, right? And that can lead to some confusion in the system. So this specification is not deterministic in nature, which is very obvious, because it doesn't say which index is returned if the value occurs more than once, as you guys observed. It simply says that if you're looking for an entry at an index, will be given by the return value where the value was found, right? So it just simply tells me that specific index will be returned. It doesn't tell me, what will happen if you have multiple ones, especially, it will now depend on the way you implement it, and based on the implementation, you can get two different values for or maybe two different indexes, right? So this specification allows multiple valid outputs for the same input. Everybody's on board with me on the last statement.
Yes.
All right.
Yes.
Now let's look at this again. This was the whole thing, right? So you will have a deterministic specification if you have, only one single possible output for a given input, or otherwise you will call non-deterministic / underdetermined if you allow the implementer to choose from legal output. Happening here, we are allowing the implementer to select. Both are legal, both are correct, but of course, this spec is non-deterministic in nature. Now, of course, we have to. I like your special attention here again. Now, this word non-deterministic is slightly has a different meaning in specification as compared to, for example, the source code. When we talk about non-deterministic source code, what we really mean that sometimes that's non-deterministic source code will behave one way, and sometimes it will behave another way. When even if we call the same method, same program with the same input. Can we think of a case where we have a non-deterministic code? Or how we get a non-deterministic code, typically? That if I give the same input, I can have multiple different inputs, different outputs or different values generated depending on every time I run the program.
We use random, for example.
Exactly. We use random, for example, right? So the moment we use random, basically, math.random, basically, depending on every time, it will give you a different one. So that is a non-deterministic code, okay? Now, don't be confused with non-deterministic code and the non-deterministic specs. Non-deterministic does not have to have a non-deterministic implementation. Like in this case, find first, is it a deterministic implementation?
Yes.
Or a find last is also a deterministic implementation. From a coding perspective, both are deterministic. If you implement find first for such a specification, you run the program millions of times with the same input, it will always give you the same output. Or if you implement the same program spec using the find last method, you run it millions of times, give the same input, it will give you the same output. So these implementations from a source code perspective are deterministic source codes, while the specs are non-deterministic. So this is the point. You can have a non-deterministic specification and you can have a deterministic implementation for it. So you can, like I just showed you, like you can have a complete satisfaction of your non-deterministic specification using a fully deterministic code. Everybody is comfortable with this concept?
Yes,
Yes.
Doctor, I have a question.
Go ahead,
Can you
please.
go back? Can you go back? Yes,
Previous slide.
Yes.
Let me go back. Yes, please.
Yes. How can we convert this specs from non-deterministic to deterministic? We can change the precondition or change the post condition, right?
Correct. Correct. Absolutely correct.
Okay. Thank you.
Yeah, great. Great observation. Yes, exactly. So everybody is comfortable with this, right? So just to put this in the slide so that when you come back you can refer to it again. In other words, this undetermined or non-deterministic specs for this find method can completely be satisfied by this find first and find last, which are fully deterministic in their nature. So, again, it depends on whether you use, whether you use the find first or find last, it will always give you the right answer. Oh, interesting point here. I'm saying again that, you could have a specs. So your non-deterministic specs could be satisfied by a non-deterministic implementation as well. Can I do it here in this case as a developer?
Yes,
How?
yes, because sometime maybe you will produce the intended value or output. Some values, but some values it won't produce it.
Now, if I'm going to implement find fast, will I be producing different values? So
No,
let's
one
say
value.
I will have the same value, correct?
Yeah.
No matter, as long as give the same input, I'm looking for the same value in the same array. No matter I run this hundreds of millions of times, I will always get the same answer, correct?
Yes.
Hence, this is non-deterministic specification. I have a deterministic deterministic code for it, right?
Yes.
Now, what I said here is that I can have, this non-deterministic specs could be satisfied by a non-deterministic implementation too. So I can even have implementation which is non-deterministic. Can I do this with this example?
Yes. You implement find first and find last.
Yes.
And put a random number to choose between them every time he runs.
Exactly, right? So I implement both, and then I will go just, as you said, put a random number. Sometimes I will run find first, sometimes I will run find last. I can do it as a developer, correct?
Yes.
So this is possible, as we said, by a toss of a coin or a random number. But of course, the reason I put them here is just to clarify to you that, don't be confused that, since I have a non-deterministic specification, I'm always going to have a deterministic implementation for it. No, you can still have a non-deterministic implementation. Of course, in this case, probably it doesn't make sense, right? Why some implementer will do it, right? Yeah, right. But he can still do it. But in more other examples where you have some random numbers needs to be used, so you can still have a non-deterministic specification which can be satisfied by a non-deterministic implementation. Everybody is comfortable with this concept? If someone is not clear, I can repeat this one because this is important for us to understand. Some show of hands will give me a bit of confidence here. Thank you very much. Okay. So, but almost in most of the cases, almost all the time, you will encounter where your underdetermined specs will offer a choice to the developer, and they will select an implementation which is most suitable for them. And of course, most of the time, your underdetermined specs are typically implemented by a fully deterministic implementation. This is most of the time, 99% of the time, unless you're really looking for random numbers and somehow you need to have a randomization in your implementation. So, but it is possible. Everybody's comfortable with the very first concept, this first dimension, that you can have different specs, and some of those specs will be deterministic in nature, and some of those specs will be non-deterministic or underdetermined in their nature, right?
Yes.
Now, when will you be interested in having, or if you go with a deterministic specification, what are you telling the developer? That you're basically pinpointing to him or her that this is the way I want it to be implemented, right? You have still a choice of the way you implement it, but this is what I want, right? That for a given value, I should have, a certain one given output. While if you have a non-deterministic specification, you're giving implementers a choice of a legal set of outputs, and you say, I don't care which one you select, this is the precondition, this is the post condition I want you to satisfy. Now this brings us to the second dimension, which is the declarative versus operational specs. Now take a moment to read the second one now. So the second criteria or dimension tells us that, does the specs just characterizes what the output should be, or does it tell you explicitly how to compute the output, right? So let's look at this now. So there are two kinds of specifications. One we have called the operational in nature. So basically, such kind of specifications basically give a series of steps that the method performs. Is like a pseudocode. So you're basically describing the operations of that specific method inside the specs. And you're basically telling a lot of details like a pseudocode. If this happens, do this. If this happens, do this, so on and so forth. So you are writing, if this is what you're writing, you're basically writing something we classify as operational specifications. While on the other hand, we have something called declarative specifications, which does not give details of these steps. It only tells you what? It says, what is the final output you're looking for a given input. Which one you believe is more advisable?
Declarative.
Declarative, yes. It's more advisable, right? Because why it could be more advisable?
Because sometimes you don't know how to operate this method or how to do it properly. Maybe.
Okay, let me repeat it. Usman, I didn't follow the comment yet. Do you want me to repeat this one, or you want me to repeat the previous one, please?
He wanted you to repeat the previous one.
Okay. The previous one, right? Is this clear now? The difference between the deterministic and undeterministic one? Was it clear to you? The previous one, okay. But I believe it's clear now to you, right? You said yesterday, right? Okay, great. Great. So we'll move on. Okay. Why we'll be interested in having a declarative? Why we believe that it's advisable to have a declarative specification?
To make it simple and
Make it simple.
to give the implementer flexibility.
Exactly. You kind of summed it up. Absolutely. So almost always we are interested in having declarative specifications. It's always preferred. It's always recommended. And the reason is, as Abdul Majid just said, they usually are shorter, they are more concise, they are easy to understand, and more importantly, they don't expose the implementation details to the client, right? And that's the whole idea of the specifications, remember, right? It acts like a firewall between the client and the implementation, right? So the client doesn't need to know the inner working of these code, right? He all needs to know is what is the precondition, what is the post condition. And of course, it also gives the freedom to the implementer to go in and develop the weight likes without really worrying about how the client will use it. So basically, we are always encouraged to use declarative specifications as a designer because A is easy to understand, short, and of course, you're not exposing the implementation details whatsoever to anyone. So for example, in our case, we want to allow the implementation of the find methods. We would not want to say, whether it goes in the find first or does it do a find last, right? We don't want to really expose this part, right? We only want to tell them that, you're able to find a variable in an array. So it's always preferred that you go on with the declarative specifications because it really gives you this true sense and achieves your true essence of writing specs. Now, one can argue with me that that okay, as you suggested and as you recommend that we should be writing declarative specifications, why people end up even writing operational specifications? The reason is that sometimes the programmers, lapse into this, or designers, we lapse into this operational specifications because we are actually using incorrectly. We're trying to use specifications to explain our code. So, we believe that, if I write operational specifications, the one who is going to come and use this piece of code, or the one who's going to maintain this piece of code, or the one who's going to write test cases, it will be easy for him to, understand the code. But that is not the purpose of specifications. Specifications purpose is to decouple clients from your implementation. If you want to explain your piece of code, if you want to explain the logic of your piece of code to the developers, to the maintainers, to the testers, don't do this thing as part of your specs. Rather, write comments within the body of your method or code and use these comments to explain your code. Everybody's on board with me on this point?
Yes.
Great. How much time we have, guys? Maybe 1 minute, right?
Yes.
Okay, so let me just finish this comparison and we'll talk about the strongs and weaks later, inshallah. So, let's stop with this one. So basically, you can express the same specs of your system using multiple options. Okay, probably I think I'm repeating this one here. So you can write them you can explain the same thing in multiple ways. It's up to you which you believe is more clearer, more precise, easier for the clients, more easier for the developers, more easier for the maintainers of the code. But you can write as a designer your specs multiple ways. What's happening here, guys? And we'll stop with this one. It's already 10:50. So what is happening in the specs?
He's describing that if this word has the same prefix as the input prefix.
Exactly, and it will give you a certain output, right?
Yes.
So let me stop it here. Inshallah. Let me stop the recording. It's 10:50 now. So stop the recording. Take the attendance. Inshallah, we use this slide as a starting point. Inshallah, on Thursday, right?